Aloha, Rich Alverson here. We're doing graphs, and in this short video, I'm going to cover depth first search. So let me share my screen. Okay, this is the depth first search section, and with depth first search, when we traverse through a graph, we always go downward before we backtrack. So if there's a path downward, if there's a path forward that we can take without going back and visiting a node that we previously visited, back where we came from, we take that path. So for example, here, if we're starting from node A, then if the next node we go to is B, then before we go back and visit D, we're going to go down all the downward paths from B. So we can go B, E, F, C, or we can go A, B, F, C, and now there's no place to go. So we go back, and from F, we can go to E because E hasn't been visited yet. And then once E is visited, we go back. Can't go anywhere, go back. Can't go anywhere because both these have been visited, go back. And now we can go visit D. So that would be a couple of different orders, traversal orders that are depth first search traversals through this particular little graph here. All right, the next important thing in this section is the actual description of the algorithm here. So we use a stack and a visited set. And we start out by pushing the start node into the stack. And then we visit nodes by popping the nodes off the stack. So we pop another node off the stack, and that's the node we visit. That's the current node. And so once we pop a node off the stack, we check to see if that node has already been visited. And that's what the visited list is used for. If the node has not been visited, then we mark the node as visited, probably put it in a little table down here, a little list down here, and we add it to the visited set. So that records it as being visited. And after that, we add all of the vertexes, all of the vertices that are adjacent to this node that we're visiting. And it's possible that a node gets added to the stack more than once. That's fine, because when it's popped off, we check to see if that node has been visited already. If it's been visited already, we skip it. Okay, so as we go along and we visit a node, we add all the adjacent nodes onto the stack, however many there are, whether or not they've been visited before. And once we're done visiting a node, we get a new node by popping it off the stack. And we only need to visit it, process it if it's not been visited before. Eventually, there will be no more nodes on the stack to visit, and that way we know we're done. Okay, so I'm gonna I have cut out this. I've done a snip here to snip out that portion of the screen because I'm going to refer to that when we do the challenge activity. Let's go down to the challenge activity. Make sure you do all these. Here's a recursive version. You can check that out. All right, so I'm going to do this one over again. So in this example here, we're fine. Enter a valid depth first search when E is the starting vertex. Okay, E is the starting vertex, and we can go to we can go. Let's go to B. Okay, E to B, and then let's go to C. Okay, we can go to C. Once we're at C, no place to go. Go back to B. We can't go to E, but we can go to A. So then A would be next. Here, let's start writing these down. Let's start at E. And then let's just go to B. Let's go alphabetical. We can go any way we want, but let's go alphabetical. Where when we have a choice, we'll take the one earlier in the alphabet. So from E From E, we'll go to B. And then from B, we can go to A. It looks like we can go to A. Okay, let's go to A. We're going to do this alphabetical thing. A. Okay, and then after A, we have no choice. We got to go to D. Okay, and then once we're at D, we can't go to E because we've already been there. So we got to go back. Got to go back to A. Is there any place to go from A? Well, it's no, we've already been down to D. So go back again. Go back to B. Is there any place to go from B that we haven't been yet? Well, we can't go to A. We've been to E. We've been to A. We haven't been to C. So now we can go to C. So now we'll go to C. So that'll be the last one we visit. Okay, and that's it. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right. There we go. These are the 3 ways that you can step through when E is your starting point. So this one is first one, E, B, A, D, C. It looks like that's what I did. Or we can go, the next one is E, B, C, A, D. And the third one is E, D, A, B, C. That's kind of a nice one. All right, what's next? Which of the following are valid depth first search traversals? Okay. Well, we start with E, and so I'm going to see if this helps me. We start with E, and so how can I? I can't really do that. So so it has to start with E. So we can eliminate 6. So forget about 6. Okay, 6 is eliminated because it starts with C. Let's just look at the first one. E, D, F. Wait, E, D, F. No. Let me keep track of this somehow. Oops. There's 1, 2, 3, 4, 5, 6, 7. We have crossed off 6 because it starts with C. That's no good. So I'm going to cross off 6. And 1, we just crossed off because E, D, F. You can't get to F. Well, there's no reason to visit F. It wouldn't be in a stack. It wouldn't be in the stack. So anyway, so let's get rid of, 1, let's eliminate 1. How about number 2 here? E, C, that's okay. F, that's okay. B, that's okay. E, C, F, B, and then A would be in the stack because when C was visited, then all 3 of these A, D, and E would get thrown in the stack. So A is a valid next visit from B because we go E, C, F, B, E, C, F, B, A, D. This is a valid one. I think this is good. E, C, F, B, A, D. That's a valid one. Okay, what's number 3? E, D, A, C, F, B. E, D, A, C, F, B. E, D, A, C, F, B. Yes, that looks like that's a valid one. I'm just E, D, A, C, F, B. And what is number 4? E, C, F, B, D, A. Yes, that works. E, C, F, B, Okay, when it goes E, C, and when C gets processed, when C gets visited, A, D, and E are going to get added to the stack, but they can get added in any order. They can be added this one, this one, this one, or whatever. So D is fine. But then after D, we have to visit A. So we're on this one, right? E, C, F, B, D, A. So this is valid. E, C, F, B, D, A. Oh, wait, that was 4. F, B, D, A. What's 5? E, D, C. Five is E, D, C. E, D, C. F, B, A. Yes, okay, so E, when E is processed, yeah, so yeah, E, D, C. Yeah, we're going down a path, down a path, down a path, down a path. E, D, C, F, B, and then come back to A. Yeah, that's a valid one too. All right, so I think that's these are all the oh, I forgot to check 7. So let me put this one. E, C, E, C, E, D, E, D, C, F, B, A. And then the 7th one is E, C, D, A, and then F, B. B, E, C, D, A, because it's always going down, visit down a path. I'm not backtracking. Down a path, and now I got to backtrack. I would backtrack here to here and then go to FB. So yes, that one's valid also. All right, so I'm just going to check. Ah, good, got it right. Okay, let's do the 3rd one real quick. Next. Enter a valid depth first search traversal when F is a starting vertex. Well, this is easy. All right. Enter a valid depth first. How about F, C, A, D, E, B? That works. F, C, A, D, E, B. F, C, A, D, E, B. F, C, okay. Enter a valid depth first search traversal when F, okay. Looks good. All right, those are all the ones. And what's the next one? DFS is run on the following graph. C is the starting vertex. Okay, we're starting here. Which vertices are in the stack before the first iteration of the while loop? Okay, so let's do this, use this diagram thingy I set up here. And let me clear this. And I'm going to have a stack. I'm going to have a stack. And I'm going to have a visited set, VS. And so this is a stack, and this is a visited set. And then I'm going to have a current V, I think, a current V. Okay. And let's see. Okay, C is the starting vertex. So that means up here, push C into the stack. So I'm going to push C into the stack. I'll use red. C. Okay, so what are the vertices what vertices are in the stack before the first iteration of the while loop? Well, it's just C, I guess. Okay. Now, given vertices A, D, E, F are in the stack after the first iteration of the while loop. Okay, yes, because after the first iteration of the while loop, C goes here, and C is not in the visited list, so C is going to go over here in the visited list. C is going to go into the visited list. Let me put C here in the visited list. And then each vertex adjacent to C gets pushed onto the stack. So that's why A, D, E, and F are pushed onto the stack. Meanwhile, C has been removed from the stack because we pop it right up here. We pop it. So I'm gonna anyway. So anyway, so C is gone, but instead we have A. Oh, let's see. We've got A, and we've got D, and we've got E, and we've got F. Those are all added to the stack because they're all, adjacent to C, and C just got processed. Okay, so given that, which vertices are in the stack after the second iteration? Okay, so this is after the iteration of the first loop. This is after the first iteration of the while loop, what we have right now. And so I want to do one more iteration and see what vertices are in the stack after the second iteration. Okay, well, the second iteration is going to take F. F is going to be the current V. And so that means F is going to be erased from here. And F is going to be added to here because it's visited. Okay, visited. And then all of the vertexes adjacent to, that's weird, that are adjacent to F get pushed onto the stack. So what are the vertices adjacent to F? Well, it's C and B. Oh. B and C. So I'm going to put B and C just because I'm going to keep it alphabetical. B and C get pushed onto the stack. F is gone, it gets replaced. F is gone, it gets replaced by B and C. And so what vertices are in the stack after the second iteration of the while loop? Well, I'm going to say A, comma, D, comma, E, comma, B, comma, C. And what vertices are in valid set after the second iteration of the while loop? Well, I think it's just C and F. Because first C gets processed, and then F is going to get processed next, because that's what the next one is. Okay, so I'm just going to say C and F. C and F. Let's see if this is right. Okay. The problem is that I thought if these were in the stack, does it say something about alphabetical or anything? No. If these were in the stack, I thought that this, since this looks like the last one listed in the stack, I thought this would be the first one pulled out of the stack. And it wasn't. It pulled out A first. Let's see. So it pulled out A. Even though all of these were pushed onto the stack at the same time, and there's no Anyway, I think my answer was correct, but they didn't think it's correct. And I think it has to do with the fact that it kept everything alphabetical. This should have been in reverse order, but so let's do it again. You get to see two of them. Okay. DFS is A is the starting vertex. Which vertices are in the stack the first iteration of the loop? It's going to be A. And assume, okay, so when A gets pushed in, let me erase, I guess I can erase this. Okay. So we're going to start out with A here. And A was here, but it got erased. A, because A was here. Currently, A is erased. A goes from here to here, and then into there. And then we see that vertices D and C are in the stack after this first iteration of the while loop. D and C, because when A is processed, its adjacent nodes get thrown in there, so D and C are going to be in here. And it says D and C, D and C. And I think because I got the last one wrong, I'm going to change this to like that, because I want D to be the first one that comes out. Okay, so given vertices, that's on the stack. What are the vertices after the second iteration? Okay, the second iteration, it's going to make, it's going to pop off the D. It's going to erase the D. And it's going to put the D in here. And D is not in there, so it goes into here. And all of the nodes around D are going to get thrown into the stack. And I'm going to throw, and so all the nodes around D are going to get thrown into the stack. So I'm going to throw them in alphabetical order, and I'm going to do A, C, and E. So I'm going to put A, C, and E. So that's what I say is what the stack looks like after the second iteration of the loop while loop. So I'm going to say C, A, C, and E. What vertices are in visited set after the second iteration of the while loop? And it would be A and D. A and D. All right. Okay. And this has CAC. This looks right. CACE. Didn't like this. Okay, so what was the matter with that? The first one that gets processed is D. So D is removed and stuck over there. And D is removed and put here. Then all of the but C is still there. You know, I think I'm writing the stack numbers in the reverse way because ECAC is here. ECAC is here. And I'm writing them in reverse order. I think that's the problem. I'm writing the stack CACE, and I should be writing the stack ECAC. So let's try this one more time. I think that's my problem. Boy, you guys are getting a good. This is a kind of a long lesson, but you shouldn't have any problems getting these right after watching this thing. So let's try this one more time. Okay. DFS is starting with B. B is the start. And so what's this? This is B. And so this is going to be B. So this was pushed on and then popped back off again. So we've got B here. And that's the vertex at before the first iteration of the loop is B. So here, before the first iteration of the loop, it's just this. And then once we iterate the loop, we pop B off the stack and we put it into current V. So B goes into here and gets popped off. And then given F is in the stack after the first iteration of the loop. Okay, so because B is the start, so then F gets thrown into the stack when B is processed. When processing B, which is right up here, puts B here, and it puts F here because F is the only vertex that's adjacent to B. What are the vertices in the stack after the second iteration of the loop? Well, it's F. They're going to make this super easy for me. What are the vertices in the visited set after this? Oh, no. After the first iteration of the while loop. Okay, so F gets replaced with what's adjacent to F, and that's C. So the second iteration of the while loop, it takes F. It gets rid of that, puts F there, puts F there, puts F here, and gets rid of that and replaces it with what's next to F, which is C. So C gets put there. So so this should be C. So C is in the, which vertices are in the stack after the second iteration? It's C. Because it's what's adjacent to F, it's what's adjacent to what's being processed. The F's not going to be there. And then what vertices are visited? BF. Okay, now I'm not going to have the problem I had before because there's no right way or wrong way to just enter in a C, which kind of pisses me off. What did I get wrong now? How did B get in there? Oh, because that's adjacent to F. Okay, yeah, C, the node adjacent to F should also be in there too. Both nodes adjacent to F, so there should be a B in there also. All right, I'm going to do this one more time. I could erase a bunch out of here, but I'm not gonna. You should be able to. After you get this right, you can just skip forward to the next one, okay? Okay, starting with F. F is going to be in here. And B and C are in the stack after F because B and C are going to be in there. I guess it's going to be B and C like this. And which vertices in the stack after the second iteration? B is the one that's processed. And B is going to be up here. And B is not going to be there anymore. It's going to be those that are adjacent to B, and adjacent to B is just F. I'm doing this wrong, aren't I? The first one is F. The first one visited is F there, so I should have an F there. And then a B. And then a B. And when B is, and so B and C, were in the stack. It was like this. Was like that, and not current B gets put there, B gets erased, and all the nodes adjacent to B get added, and it's only F, so it's F here. And what are the vertices? What vertices are in the visited set after the second iteration of the while loop? FC. And what is in the visited set? FB, I guess. All right, so I hope that helps. What's the next one? Recursive depth first search is run, and the following graph assume B is a starting vertex, so B is a starting vertex. Which of the following is the call to the function? It's going to be this one. The starting vertex is B, so it's going to be this one. Oh, this is a recursive. This is recursive. Okay, so you have to understand, or you have to have studied this algorithm here. Current V is with the starting one, so it's that. If F is not visited yet, recursive DFS F will make subsequent calls to. If F is not visited yet, recursive F will make subsequent calls to see. It's going to call for each vertex adjacent to something that's going to call it. So that means it's going to call. So when we call this, it's going to call it on both B and C. Okay, because it calls both of them. So I'm going to say B and C. Oh. Wait a minute. No, it's going to go to. No, I guess it's going to be B and C because recursive DFS F goes through this loop. DFS F is going to call recursive DFS on the vertexes that are adjacent to the current node, current vertex. So I'm going to say that's the answer. And it looks like that's the answer. All right, well, we stumbled a little bit on step 4, but now there's no question. You should be able to zip right through that. You can skip to 5 if you need to. Hope this helps. Thanks for watching.